This is question 1 from the first CSAT sample paper. In this question we've got a square, the side lengths we're told are 10 centimetres, and we're told to cut out the corners and then fold it up to make a box. So our box is looking like this. This central part here is going to be the base of the box, and then by taking out these corners we've got all these flaps at the side, and those fold up and those make the edges of the box. And we've got to figure out the maximum possible volume of this box in terms of cubic centimetres. So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, we're going to need a variable to work in terms of, and it makes sense to use the length we're cutting away. So if we call that x, what are the other lengths? Well, this is x, and then the other side here is x, so we get 10 minus 2x centimetres for this length. And then if we compare to this box, how is that going to give us the volume? If we look at this, look at the base, that's a square, and the side lengths are this, and then the height of the box is x. So when we go to write down the volume, we're using a square of this side length times this height. Okay, so here's my formula for the volume. This is the height of the box, and the base, the side lengths are 10 minus 2x, and that's squared because it's the area of a square. So what are we going to do with this now? Well, we want to find the minimum value. We can see it's going to be a cubic because we've got x times a quadratic. So it makes sense that we'll want to differentiate this with respect to x to find the minimum. And that means we probably want to expand out first, because that makes it easier to differentiate. So let's do that. We want to expand this in times by x. One thing that's useful is it might be easier to think of this as 2x minus 10 in case you're used to dealing with x as the leading value. So this squares to 4x squared, then we get minus 2 times this, minus 40x, plus 10 squared is plus 100, and then we times it all by x, so we just put an x into each of those terms. And now we want to differentiate with respect to x. So I bring the 3 down, I get 12x squared, bring the 2 down, minus 80x, this just becomes plus 100. And now for a turning point, so for a minimum or a maximum, we want the derivative to be 0. We've got a quadratic here, so it makes sense to try to factorise this if we can. I think it's easiest first to take out 4 because that makes the numbers easier to deal with. Then we're looking at, once we're taking out 4, 3x squared minus 20x plus 25. We can see if we can factorise, then we're going to want 3x and x as the x terms in our two brackets. And to get 25, we either want 1 and 25 or 5 and 5. And it makes sense it's going to be 5 and 5 or the numbers would be too big. So the obvious thing to try is 3x minus 5, x minus 5 to get minus 20, and that turns out to work. So this is the factorised derivative. And that means, well, we want this to be 0 for a minimum, so that means we're getting a minimum when one of these brackets is 0. So either x equals 5 or x equals 5/3. So which of those is the minimum? We could differentiate a second time, but that's going to take too long. We can do this just by looking at it. What happens if x is equal to 5? Well, remember that if we go back to our picture a second, we had x here and x here, so this is going to be 5, this is going to be 5. The total length is 10, so that means we're getting a length of 0 in the middle here. So that basically means we cut out the whole of the square, and that means the volume is going to be 0. So that's the minimum possible volume, but we want the maximum. So going back to this line, we know we don't want x equals 5 because that gives us v equals 0, obviously. So we're going to want x equals 5/3 to be our length. And then because they asked for the maximum volume, we need to then go and plug this into the formula for the volume to see what the volume actually is. Okay, so I've written down our formula for the volume again, and this is the value of x we're using. So now we can just plug that in. We get 5/3 here, and then 2 times 5/3 is 10/3. We could have taken 2 out of the whole thing, but I don't think it makes it any simpler. So it's easier just to make this 10 minus 10/3 inside. And then this is going to come to what? if we put it all over 3, 30 minus 10 on top is 20 over 3. So that means we're doing 5/3 times 20/3 all squared. That's 20 squared over 3 squared. So on the bottom we can see we're going to get 3 times 3 squared, that's 27. On the top, this is going to be 400 times 5 is 2,000. So we get 2,027ths, and I've written centimetres cubed because the silents are in centimetres, and we can't cancel this, so this is our final answer.